Okay, so I've got a steel shaft diameter, okay, going through some bearings. The motor delivers 12,000 watts of power at 50 revolutions per second. Um, so at each gear, it pulls off some amount of um, power to drive something as shown there. Okay, and I want to find the maximum shear stress in element CF and BC. So what I need to do, okay, is, again, my equation is tau equals TC over J. Okay, so I need to find the torque in each segment. And again, to find that torque, I just use the power divided by the rotational speed. Okay, so for what we have here, I have rotational speed equals 50 revolutions per second. Of course, I want to get that in radians, so I'm going to multiply that times 2 pi. So my speed, I'm just going to leave as 100 pi. And again, that will be in radians per second, which is the units that I want. Okay, so from that, now I can go through and figure out the torque in each segment. So this first segment has the full power going through it. Okay, this is segment CF, so that's going to be 12,000 divided by 100 pi. Again, that's the power divided by the angular velocity. Okay, then it pulls off 5 kilowatts. Okay, so between B and C, I'm going to have 7,000 divided by 100 pi. Pulls off another 4,000 kilowatts. And what I'm left with is 3,000 divided by 100 pi. And that last segment, well, I've got nothing left, right? So there's zero power going through that final segment that I've got going there, okay? Now, again, now that I've got the torque in each segment, now I can find the maximum stress in each segment just using TC over J. So to find the stress in CF, okay, it's just going to be the torque through CF, which again is 12,000 divided by 100 pi, okay, times C. Now again, this is 25 millimeter diameter. I need radius because it's the maximum distance from the center that I can get. So that's going to be 0.0125 divided by the polar moment of inertia, which is pi over 2 times 0.0125 to the fourth. And from that, I can find that the maximum torque, or excuse me, the maximum shear stress due to torque is 12.45 megapascals through member CF. Now, doing the same thing for member CB, everything's going to look the same, except instead of 12,000 over 100, it's going to be 7,000 over 100 pi. Okay, times 0.0125 divided by pi over 2 times 0.0125 to the fourth. And from that, I find that I get 7.26 megapascals. So again, find the torque in each section. From that torque, and you do that by taking P divided by omega from that torque. You can then find the stress just by taking that torque, TC over J, and you'll get the answer that you're looking for.